Hello and welcome. In this video, we are going to talk about the area formed between two curves and how to use calculus to determine what that area is. So let's jump right in. Okay, so the first thing, I just want to think really generically about what we're talking about here. Here we have an area that's being formed between this curve and this curve. And I actually don't want you to use any calculus at all. I want you to find the area of that shaded region. I'm going to call it A. Find the area of the shaded region A. All right, well, hopefully you have had time to do that, and you just did some basic geometry to say that that's just a triangle, and the area of the triangle is 1/2 the length times the height, which in this case is 1/2 of 3 times 3, which is 9/2. And since we're talking about area, we're going to say u squared for units squared. So the idea is that we created area in an xy coordinate plane between two functions. One function being this line, and the other function being this line. And I guess you could keep in mind also that we're using the y-axis. Now, what would happen if we were considering area that didn't form a basic geometric shape? For example, if I drop this picture in here, I know you can't see the functions, but what would happen if I asked you to find this area of this A shaded region? I want you to ask yourself whether or not the same strategy would work here. And the answer is no. I can't use the area of a triangle or a rectangle or a trapezoid or a circle or anything. The area of this shaded region is not, there's no area formula that we know to find the area of that region. So the idea in this section is how can we take what we know about area and what we know about integration. If integration is the area under the curve bounded by the x-axis, could we use the idea of integration? And we're going to start with this really basic example. Could we create an integral that finds this same area so that we can use that idea to find area like in this example below? Okay, so if we were going to create an integral, we would first need to talk about what functions we would be finding the area of, or what functions we would be using. So go ahead and pause the video and identify what that red line is and what that green line is. So hopefully you were able to identify that we need to use the line y equals x and we need to use the line y equals 3. The next thing I want you to think about, I'm going to erase a little bit of this here so that we can kind of get more of a visual, is if we were forming the area with the x-axis, which curve is on top? Which curve is forming that area? And it looks like we're forming area this way. So y equals 3 is our top function. And actually, if we just integrated 3 with respect to x, that would give us this whole area under the curve. And let's actually talk about where are we integrating from. Well, we're integrating from here to get this width of our triangle, and that's from 0 to 3. This would give us the area of this square, 3 by 3, which is 9. But what we really want is not to go all the way from y equals 3 down to the axes, but to stop when we get to this line here, which means this line, if I found the area under the curve of this line, that area would be the integral from 0 to 3 of x dx. So if I just want, I know I've applied a lot of color here, but if I just want this area, I need to take the red area and I need to subtract the green area. I need to find the area of that whole square, the entire curve, y equals 3 from 0 to 3. And then I need to subtract out the area that's overlapping here. So since these two integrals have the same bound, I'm going to go ahead and just combine them into one integral. And then let's go ahead and apply the power rule 3 is going to become 3x after we integrate it with respect to x. X is going to become negative x squared over 2 after we integrate it with respect to x. And we're evaluating it from 0 to 3. Those are the bounds on the integral. So now we can go ahead and plug in the top value. So 3 times 3 minus 3 squared is 9 over 2. And if I plug 0 in, I'm just going to get 0. 3 times 0 minus 0 squared over 2. So this is going to become 9 minus 9 over 2, which is 9 over 2 units squared. So we're getting the same answer. So the idea that we just did was we figured out which function was forming the top area, that was our red function, and which function we wanted to stop at, or how far we wanted to cut below, and that was our bottom function. So each time we're setting up this integral for our different areas, we want to think about what are the bounds, what's the top function, what's the bottom function, and how can I set up the integral to find that specific area. So let's look at another example. So here's the rest of that problem I was pointing out before. And what I want you to see is the very first thing we're going to talk about is what are our bounds. So ask yourself, where does the area start on the left, or where does the shaded region start, and where does it stop on the right? So if I look, I'm going from here to here. Those are going to give me the bounds of my integral. Now, I can see this graph pretty clearly. It looks like that's happening at the point 1, 3, and at the point 3, negative 5. But oftentimes you're going to be creating the graph, or you're going to be given a graph that's not so clear. So I want to make sure we know how to calculate the bounds by hand. The bounds of our integral are going to occur where these functions are crossing. So when is f of x equal to g of x? So we're just going to get everything on the same side. So I'm going to add x squared and subtract 4. So x squared minus 2x minus 3 is 0. This is going to factor. And this is going to give me x equals 3 and negative 1. So those are going to be the bounds of my integral. So eventually I'm going to set up an area integral. And the lower bound is going to be the smaller x value I found. And the upper bound is going to be the larger x value that I found. Now we need to figure out what's going on with our integrand. The integrand is just the inside of the integral, so we need to figure out which function is on the top and which function is on the bottom. And I really do mean go to the top of the area and trace it. What function are you tracing when you're tracing the top of the function? Well, I'm tracing the quadratic, not the line, so my top function in this case is going to be negative x squared plus 4. I want to subtract the bottom function, which function is creating the bottom piece of this area, and that's the line, which is negative 2x plus 1. And there we go. I'm going to go ahead and simplify this. So if we distribute this negative sign, we're going to get plus 2x minus 1. And then if we combine like terms, negative x squared is going to stay the same, plus 2x. And then we have positive 4 and negative 1, so this is going to be minus 3. So this piece right here is going to go inside the integral for our integrand. So the first thing we're doing is finding the bounds. Where do the two functions cross? Then we're figuring out which function is on top and which function is on the bottom so that we can find our integrand. And now we're just going to evaluate this area integral that we have come up with. So if we apply the power rule, I'm going to get negative x to the third over 3 plus 2x squared over 2, which is just going to become x squared, plus 3x. And we're going to evaluate this from x equals negative 1 to x equals 3. So let's go ahead and plug 3 in. 3 cubed is 27, divided by 3 is 9, so negative 9, plus 3 squared is 9, plus 3 times 3 is 9. Minus, if I plug negative 1 in, I'm going to get 1/3 plus 1 minus 3. And then we're going to go ahead and simplify this. This whole thing is going to become 9 minus, Over here, we're going to get negative 2 plus a third, so that's going to be negative 5/3. And if we combine these, we're going to end up with 32 over 3 units squared. So step 1, find the bounds. Step 2, figure out which is your top and bottom function for your integrand. Step 3, set up the integral and go ahead and evaluate it at each of the bounds. And then don't forget that your final answer should have units squared. So we're going to talk about one example, almost working in reverse, just to tie this to what we've been doing all semester with integration. Talk about some hints and tips, and then we'll move into just a few more examples to wrap up the video. Okay, so here, instead of being given two functions, we're given the integral, which is something we could have seen at any point in time after we learned the power rule. And we're being asked to sketch the situation, identify the two functions, and then find the area. So thinking about what we just did, our bounds tell us that we're looking for the area between x equals 0 and x equals 4 of the two functions that we're finding the area of here. Here's our first function, so I'm going to say f of x equals x plus 1, and g of x is our second function, x over 2, which we could also write as 1/2 x. Now remember, we're supposed to be subtracting the big function minus the smaller function, so the functions are both positive in this case, not negative, even though we see negative x over 2. So let's go ahead and do a quick sketch of what's going on, just so that we can get an idea here, because what we're talking about are two linear functions, and two linear functions can either cross once, they can be parallel and never cross, or they can end up being the exact same line. So we're not going to have a beautiful bounded region like we did on number 1, where everything was perfectly enclosed and bounded on all sides. So I think it's really going to help us get a visual idea of what's going on here to just sketch these two lines. So y equals x plus 1, or f of x equals x plus 1, has a y-intercept of 1 and a slope of 1. So we're going up 1 and over 1. And then, what was our other one? 1/2 x has a y-intercept of 0, up 1 over 2, up 1 over 2. So the key thing in this problem is that we are being told that we are integrating, we're finding the area between x equals 0 and x equals 4. So even though it's not a bounded area, we are given limitations to talk about this area right here. So let's go ahead and evaluate the integral, and that's just really something we could have done before today. I'm going to encourage you to combine like terms combine these two terms before you integrate. So this is the same thing as the integral from 0 to 4. If I have 1x and I subtract half of an x, I end up with just half of an x. And go ahead and pause the video and work through this integration on your own, and then unpause the video and see how you did. So hopefully you had time to look through this. You're going to end up with x squared over 2 times 2, or x squared over 4 plus x from 0 to 4, which is going to simplify to be 8. So you can start with the integral and work backwards to figure out what the two functions are and where we're finding the area between. Let's go ahead and summarize sort of the key ideas before we work through our last few examples. Okay, so to put it simply, finding the area between two curves is really integrating between where they intersect or between some specified bounds, the bigger function, or the top function, minus the littler function, or the bottom function. Integrating that with respect to x. When we're doing that, the first thing that we're going to do is find the bounds, which is where the two functions cross, or a problem might specify specific area that we're talking about, just like in the last example. After we find the bounds, we're going to find our integrand, the inside part of the integral. So we're going to figure out what f of x minus g of x is, or what the big minus the little function is. Then we're going to set up and evaluate our integral. to get our area, and we're going to make sure we don't leave off our units squared. A couple of tips: you're always going to need to find the intersection. Most of the time, you're going to have to sketch your own graph. If there is a graph given to you, you can identify them from the graph if you can tell what they are, but I would at least mentally check to make sure you're using the right x values so that you know you have the right bounds. If you're not given a graph, set the functions equal to each other and solve just algebraically, and then make sure that that makes sense based on the way that you sketched your graph. After you've found the bounds, then you're going to identify which function is bigger or on top and which one is smaller or on the bottom so that you can subtract them and come up with the integrand. Then you're going to set up your integral and evaluate the area. Simplify as much as possible before you integrate. It's going to make your life easier. And then remember that you need to be clear with your work. You're telling the story of how you came up with this area sort of step by step so that someone else, usually me, can look over and decide and determine what you did to get from one place to the next. So let's look at another example. All right, sketch the situation if no graph is given, then determine the integral that would find the area bounded between the two curves. Evaluate the integral to find the area. So I encourage you to pause the video and go ahead and sketch g of x equals x squared and f of x equals x to the third. And then unpause the video and see how you did. So one thing that I want to point out when we're sketching these graphs is that we are not perfect. And sometimes it's hard to tell, especially on a graph like this. I can see that I'm forming area, but I don't feel incredibly confident that I can say with certainty that the parabola is the function that's supposed to be on the top and that the cubic is the function that's supposed to be on the bottom. So when we get to that part, setting up the integrand, I'm going to talk a little bit more about that. I do feel like I can tell from my graph what the bounds are. If you can tell from your graph, then you can go ahead and just say, we're looking at x equals 0 and 1. But let's mathematically prove that to ourselves. We want to know when are our two functions equal. So get everything on the same side, factor out the greatest common factor, and we do in fact get 0 and 1. So when we eventually set up the area integral, we're going to be integrating from 0 to 1. Now, if you cannot tell with certainty from your graph which function is on top or creating the top of the area, there's a couple things you can do. The first thing you can do is say, okay, well, I only care about what's happening between 0 and 1. Let's pick a number between 0 and 1 and figure out which of these functions is bigger, because then I know which function is the bigger function and I can subtract the smaller function. So let's start with that. Something between 0 and 1 is 1/2. If I plug in 1/2, I get 1/4. If I plug in 1/2, I get 1/8. 1/4 is bigger than 1/8. So my integrand, big minus small, should be the quadratic minus the cubic over this particular section that we're looking at. Let's say that when you were working through this, you were incorrect. The only thing this is going to affect is that it's going to give you a final answer that's negative, right? Because what you would have said was x to the third minus x squared. When you integrate and when you evaluate, everything is going to give you the same numbers. You're just going to be subtracting them in the opposite order, which means you're going to end up with negative area. And that's just telling you that you flipped your integral. So I'll show you how you can solve that problem afterwards. But let's go ahead and set this up now. X squared minus x to the third dx. Go ahead and pause the video and find the antiderivative here and simplify down your area. So hopefully you were able to simplify down to get positive 1/12. But I want to go back to what I was talking about before. Let's say that you were doing this and you accidentally thought that your cubic function was bigger, and then you evaluated this and you plugged in 0 and 1. What's going to happen here is you're going to end up with 1/4 minus 1/3. If you do the same sort of common denominator work, you're going to end up with negative 1/12. And if you get a negative value, that should be telling you you identified your big and little functions incorrectly. Now, don't just say, so obviously the area is 1/12. That's not clear, and it's not showing that you understand where your mistake was. Here's what I want you to do. I want you to just go back to your original integral and put a negative in front, because really we want the opposite of the area that you just found. Come back to this step and put a negative in front. We want the opposite. Notice I'm using parentheses there. We want the opposite of the area that we're finding. Come down here, put a negative. We want the opposite, and then you can make this positive 1/12 units squared. So if you get a negative area, that's telling you that your integrand was switched from the way you want it to be. So to fix that, you can just put a negative in front of the integral instead of erasing and reworking through the entire problem. Okay, let's do 2 more examples together. The next one I'm going to make sure you have a graph for, and then the last one, it's really going to be, can you start to finish do an entire problem like this? All right, I really want you to see if you can get through each of the 3 steps on your own. So the first thing I want you to do is go ahead and pause the video and find the bounds of the integral, and then unpause the video and see how you did. So hopefully you had time to work through that. If you can tell from the graph what the bounds are, that's great. And again, I don't have any issue with you kind of pointing that out based on the graph. A lot of times you're not going to be able to tell, so it's important that you know how to do it, especially if you're not given a graph. You just set the 2 functions equal to each other and solve. Now I want you to figure out which is the big and which is the small function so that you can set up the area. And if you're struggling with this, physically trace the top part of the function of the shaded area. Ask yourself, which function am I tracing? Which function draws the top of this shaded region and which function draws the bottom? So go ahead and set up the integrand. So hopefully you noticed if I trace the top of this shaded region, I'm tracing the line. So the line minus the parabola, because again, it would be like I'm forming the area with the line to the axes, except instead of going all the way to the axes, I'm stopping at the quadratic. So I need to actually distribute this negative and combine like terms to figure out what my integrand is going to be. So this is going to be negative x squared plus 4 is going to be the inside of my integral. So now I'm going to encourage you to pause the video, set up your area integral, and work through the rest of this problem on your own. All right, so hopefully you have the integral from negative 2 to 2 of negative x squared plus 4 dx. You find the antiderivative to be negative x to the third over 3 plus 4x, and you're evaluating that from negative 2 to 2. And then just check your fraction work and your combining of like terms. You should end up with the final area equal to 32 over 3 units squared. And pause the video if you need more time to check through the work. All right, we've reached our final example in the video. What I would like you to do is try to complete this problem start to finish on your own. What I'm going to do is sort of pause at little brief moments so that you can check in. So the first thing that I'm going to do is set up the graph and then find the bounds so you can unpause the video to sort of check yourself as you go. I'm also going to walk through how to graph the quadratic in case you have forgotten. So go ahead and pause the video and try and work through this on your own, and then unpause the video and see how you did. So you shouldn't have any issues graphing this line. Y-intercept is 1, the slope is 1, so up 1 over 1, up 1 over 1, connecting. Now the quadratic, in case you have forgotten how to graph a quadratic, it happens every once in a while. In order to graph a quadratic, what we really need to know is where the vertex is. After we know where the vertex is, we can just use the fact for this quadratic that there's no stretches or shrinks, and so use the parent function to work with the transformations. So the first thing I want to do is find the axis of symmetry, remembering that a is the number in front of x squared, b is the number in front of x, and c is the constant. X is equal to the opposite of b over 2a, which in this case is negative 4 over 2 times negative 1, or just x equals positive 2. Negative 4 divided by negative 2 is positive, x equals positive 2. To find the vertex, that's the x value of the vertex. To find the y value, I just need to plug that back into g of x. So g of 2 is negative 2 squared. Well, 2 squared is 4, so negative 4 plus 4 times 2 is 8, plus 1, so that's going to be 9 minus 4, which is 5. So the vertex is at the point 2, 5. 2, this is 3, 4, 5. I didn't really save myself enough room. There is a reflection. This graph is opening downward, but there's no stretches or shrinks. So I can just go over 1, down 1, over 2, down 4. And then I can connect the dots. Pardon my not very curvy looking quadratic. Now, as I said, I am not perfect. I can tell that the area that we're looking for is in here. And it kind of looks like, I'm not positive, but it kind of looks like the bounds, maybe x equals 3 and x equals 1. Since I'm not sure from my graph, I'm going to go ahead and just calculate it by hand. So set the two functions equal to each other, get everything on the same side, factor, and I'm going to get that the bounds should be 0 and 3. So now if you think you can finish the rest of this problem on your own, go ahead and work through it, find your integrand. So hopefully you've worked through that part. I'm asking myself, if this is my shaded region, which function am I tracing to make the top? And that is the quadratic. So I'm doing the quadratic minus the line. So here's my quadratic. I'm going to subtract the linear function, and I'm going to go ahead and distribute that negative and combine like terms. So minus x minus 1, so this is going to become negative x squared plus 3x. So this is my integrand. So if you haven't already, go ahead and set up your area integral and evaluate that. So we're going to integrate from 0 to 3 of negative x squared plus 3x. That's going to give us negative x to the third over 3 plus 3x squared over 2 from 0 to 3. If I plug in 3, negative 27 over 3 is negative 9, plus 3 squared is 9, so 27 over 2, and then when we plug in 0, we get 0. So we just need to combine negative 9 and 27 over 2, which this is just negative 18 over 2 plus 27 over 2, which is 9 over 2 units squared. If you got to the end of this problem and your answer said negative 9 over 2, that's where you need to come back up here and put a negative, put parentheses around this, put a negative, and just say you're taking the opposite of the area the entire way through. So in this video, we talked about how to find the area between two curves by setting them equal to each other to find the bounds, by figuring out which function is forming the top portion of the area and the bottom so that we can set up our integrand, and then by evaluating the integral and including units squared at the end of our area. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.